Hi everyone, welcome to this session. Today we will be solving this interesting interview question. Okay, and this question can be asked for your online assessment test as well. Okay, so there is a this circuit is op-amp based, right? Op-amp based RC circuit, and here we have to find what is the output time constant. Okay, in second, and here we have a V in of 3 UT. Okay, so now how you like to solve this problem. So for time constant, we know we need R equivalent and C equivalent, right, to find the time constant, and this is the tau, right? So this is the time constant of a circuit, and we can see this is a normal single pole system or first order circuit. So time constant will be this equation, right? And here we have given that the op amp is ideal, so this is ideal op amp. Okay, ideal op amp. So to find the R equivalent or C equivalent, what we do? We deactivate all the independent sources, right? Independent sources. What is means? It means if we have a voltage source like that, this will be short circuited, and if we have a current source, then it will be open circuited, right? So now for this circuit, you will say this Vin is a independent source, so this will be short circuit, so this will be grounded, right? And yes, that is all, and this is ideal op amp. So for ideal op amp, these two nodes are same, right? This is virtual short concept, right? So if this is grounded, so this node will be must be grounded, right? Must be grounded. So this 1 ohm element, this 1 ohm resistance is dead. Okay, this is put nothing in the circuit for finding time constant thing. Okay, now what is the R and C equivalent here? So C is nothing but like the C equivalent is nothing but this C only, right? So this C, and what is R equivalent? You will say the R equivalent is nothing but this 1 ohm resistance, this RF. Okay, this feedback resistance. Okay, and let's say this is R1. So you will say the equivalent resistance is RF only, and you will say the time constant tau is nothing but C into this 1 ohm resistance, this RF, right? So you will say C into 1, so this will be C only. But here you can see the capacitance value is not mentioned, right? Here, so you will think the question is wrong. Okay, there is insufficient data in this problem, but this is actually wrong. Okay, we cannot do right, like uh, like we cannot do this, okay, for this question. How we cannot do this, I will tell you at the end of this video. Okay, now let me, so this is the wrong answer. Okay, this is the wrong answer. So let me draw the internal structure of a MOSFET, internal structure of a op amp. Okay, so then you will understand. Okay, so for a MOSFET, for a op amp, so this will be the thing, right? So this is ideal op amp, right? So this output impedance is 0, right? And there is a cap of C, and here, so this negative terminal we have this, and here we have this. This is RF, this is R1, this is our Vin, right? And this is our plus minus A times Vin. Okay, so this is the internal model of a op amp. Okay, now so we have to deactivate this portion, right, to find the time constant. So if this portion is uh, like grounded, so V in is grounded, right? Then what is the voltage at this node? Can we say? So this is not the V, so this will be VD, right? So this is the VD thing. So actually it is, if like this is ideal op amp, right? So this node, this dependent voltage source is 0, right? Because this VD is 0, right? This VD here is 0. So now if this is ground, this is 0 na, so this will be short circuited, right? So now the equivalent model will be the following. Okay, so equivalent model, so this will be short circuited, there is no resistance at output of this op amp, and there is RF and there is R1. Sorry, this is R1 and this is RF. Now, so this, okay, so let me, this is V in, this is grounded and this is also grounded. So now find what is, and this is the output. What is the R equivalent here? So we can see directly the output, like the equivalent resistance here is 0, right? Because a short circuit path to the ground is having 0 impedance, and 0 parallel something, some finite value is 0 always, right? And C equivalent is C itself. So the time constant here is 0 times C. So this will be 0. So 0 is our right answer. Okay. So this 0 is our right answer for this particular problem. Okay. Now the intuitively how we can directly say the time constant, output time constant will be 0. Basically for an ideal op amp, it can deliver any current, like instant current, to any load. Okay, there is a capacitive load here, right? So instantly, for an ideal op amp, the op amp can charge any output capacitor instantly. Okay, instantly. So the time constant is always 0. Like it can charge this capacitor in 0 time. Okay, time equal to 0. So for an ideal op amp, it will charge the capacitor like that. Okay, so it will be like that. Okay, from 0 volt to sufficient, or for a, like it can go up to its dielectric breakdown, right? So it will charge, for ideal op amp it will charge at t equals 0 seconds. Okay, so V out will reach at peak, at its maximum value at t equals 0 second. Okay, so this is the intuition behind a ideal op amp properties. Okay, so it can charge instantly to a voltage. So this question is very important. So actually like when I solved the question first time, so I did the mistake like this. Okay, so I did this thing. So this is absolutely wrong, and this is the correct way to solve. Okay, so thank you everyone. You can give your valuable feedback, and this question is asked by Texas Instrument. Okay, so thank you.